Unconventional way of cooking eggs? Well, this is no ordinary egg. And in a moment, I'll be showing you the link between this and aircraft safety and what ladies' hairdressing has to do with both.
Thank you, Peter. I'll have it hard-boiled. Good evening and welcome live to our Tomorrow's World studio. Tonight, how this machine is uncovering the ancient history of York. Peter reports from Science City on Japan's plans for space, and how by 2020, having heart surgery could become as quick and simple as a visit to the dentist. First, though, we're going to go back to Peter and see how his egg's coming along.
Well, we'll find that out in just a moment. But this torch here is producing a temperature of 1200 degrees Celsius. Now, try cooking an ordinary egg like that, and in a very few seconds, the results would be quite an explosion. But I'm going to leave this torch here, blowing on this egg for a couple of minutes before we crack it open. And it ought to survive the inferno because it's coated with a remarkable new plastic. What it's made of is a closely guarded secret. All the inventor will say is that 20 years' experience as a ladies' hairdresser led him to the discovery. Well, now several aircraft manufacturers want to test the material for fireproofing. And NASA has even asked for some samples to see if it might be suitable for the space shuttle. There is actually no legal requirement for the materials that make up the outer structure of an aeroplane, whether of a military jet like this type or even of passenger planes, to be fireproofed. And perhaps surprisingly, the aircraft skin can and does burn right through in a matter of seconds. Now, this is a Hawk aircraft, the same type that's used by the Red Arrows, and like most planes is made largely of aluminium alloy and on the wings a carbon composite material with a honeycomb core. This makes it incredibly strong but also very light. But it does have one weakness. In a fire it can burn very easily. Over here we have a similar composite honeycomb material, and as soon as I start putting a flame on it, within a very few seconds it catches fire. But not only that, it's also giving off an enormous amount of very toxic fumes. Take the flame away, and it still carries on burning. But here we have exactly the same material, which has been coated on one side with just a millimetre or so of the new plastic. Now, that doesn't add very much weight to it, but it does give it enormous protection against fire, which would be very good in a fuselage, for instance. There are other materials that do a similar job, but they often produce toxic fumes or smoke, which this doesn't. Or they can't easily be moulded. And being a plastic in its own right, this can. And of course, like on our egg, it can be used neat as a coating. So how is it doing? Well, it hasn't broken up at all, and you can see on the front here it's glowing red hot. But just watch this. If I turn the flame off, and remember that it was producing 1200 degrees Celsius, and I take that charred bit and I put it flat in the palm of my hand, it only just feels warm. And if I then crack it open, what's more, the egg hasn't even begun to start cooking.